So before I begin, I'd like to introduce SAHMRI. So some of you might notice that there is a fair bit of development across North Terrace over the last 5 to 10 years. And SAHMRI is situated right smack in the middle of the Adelaide Biomedical Precinct. We're right next to the Royal Adelaide Hospital, and we're about 5 to 10 minutes away from both the University of Adelaide's Health and Medical Sciences building, as well as University of South Australia's Health and Innovations building. Now, in the next couple of years, we are building the next SAHMRI 2, which will house the first proton therapy unit in the Southern Hemisphere. Now, depending on which way you drove this morning, you might have encountered this building, and some might call it the cheese grater. And this is where SAHMRI is. And SAHMRI is home to more than 800 researchers spanning from bench to bedside research that are seeking to tackle the biggest health problems in the community. We are divided across 4 different themes with the opportunity to collaborate across multiple different themes. And I apologize for the small writing, but I'll just highlight the themes here. So first we have SAHMRI Women and Kids, who are looking to promote healthy mothers and babies. We also have a strong Aboriginal health equity theme, headed by Professor Alex Brown, who seek to bridge the gap between health in the Aboriginal population as well as the wider community. We have a theme termed precision medicine, and this is identifying key, unique treatments that are specific to targeting various forms of cancer, and this could be in the forms of gene editing. Our final theme is lifelong health, where we seek to promote lifelong health. And this is divided into heart and vascular health, nutrition, diabetes and metabolism, as well as mental health and well-being, seeking to promote and extend your health lifelong. So our platforms range from discovery and preclinical, leading towards clinical and translational platforms. So we're looking to seek therapies that we will discover that will help promote health in the future. And a lot of my work is primarily focused in the discovery and preclinical platforms. But what I'll show you today is some of the insights from our research that will hopefully lead to clinical translations in the future. And if you're interested to hear a little bit more of the research that we do here at SAHMRI, we run public tours every fortnight on Thursdays, and we will bring you into the building. And this is some of the pictures of what it looks like on the inside. So here you see the helical staircase that connects all the different floors, as well as another angle from the building from our reception area. So if you're interested in finding out a little bit more, feel free to come along. So let's get to the heart of the matter. Today I'll talk to you about heart disease and diabetes, and how they're strongly related and what you can do to prevent it. Now, we know that diabetes is a global epidemic with a projected 642 million people, or 1 in 10 individuals predicted to be living with diabetes in the next 20 years. This has significant impact both on health and economic burden worldwide. Now, if diabetes was a country, it would be the 3rd largest country in the world. So this gives you an idea of the impact that diabetes has. Currently, 1 in 2 adults with diabetes do not know that they actually have diabetes. So this highlights a gap in terms of treating approximately 212 million people. It accounts for nearly $700 billion, or 12% of global health expenditure, and lives lost globally from diabetes amounts to 1 every 7 seconds, or a total of 5 million annually. Now, a little closer to home, 280 Australians will develop diabetes every day. That's 1 person every 5 minutes. And by the end of my talk, an additional 6 people will develop diabetes. Currently, there are 1.7 million Australians who have diabetes, and that's the population of South Australia. Of this, though, only 1.2 million people are registered and know that they have diabetes, which leaves a staggering 500,000 people who have diabetes and do not know that they actually do. So early detection would be key in terms of managing the outcomes of diabetes. Now, this again has a significant impact on global health, on Australian health expenditure, with nearly $15 billion spent annually on treating diabetes and its vascular complications. Now, what is diabetes? So blood glucose is your cell's main source of energy, and it comes from the food that you eat. And if you think of insulin, that's an enzyme in your body, it helps convert the glucose into cells to be used for energy. So insulin is sort of like a key to a lock that allows the conversion of sugar to energy so that your cells can use. And diabetes develops when you have too much sugar in your body that your body actually can't handle it. So in the context, and this could occur across multiple different ways. So for example, if you have type 1 diabetes, which accounts for 5% of the population, there is no key. The insulin is not present in the body and it's not allowed to unlock the lock. However, if you have type 2 diabetes, which accounts for 90% of the population who have diabetes, there are two different conditions. The insulin itself is unable to unlock the door properly, or the insulin is there but the lock doesn't work properly. So this increases the amount of sugar in your blood vessels and in your body, and that has downstream significant health impacts. Now, some of the risk factors for type 2 diabetes can be divided into non-modifiable, or things that you cannot change, and this includes your age, your ethnicity, a family history of diabetes, as well as a history of gestational diabetes. There are also things that you can change, things that are called modifiable risk factors, and some of these risk factors include high blood pressure, physical inactivity, obesity, and high blood cholesterol. Now, switching gears slightly, I'd like to talk to you about heart disease, which is the focus of my talk. Now, while we call it heart disease actually also encompasses all the blood vessels in your body. And depending on the blood vessels that supply the different tissues, this could lead to significant complications. So if it affects blood vessels supplying the blood to the brain, this could lead to a stroke. If it leads to blood vessels that supply blood to the heart, this could lead to a heart attack, or what we call coronary artery disease. And also there is a significant number of people with diabetes who also experience peripheral artery disease, which is impacting the blood vessels that supply the blood to your lower limbs and legs. Now, heart disease is one of the main processes that drive heart disease is a process called atherosclerosis. And this is a process that develops over several decades. And what happens in your body through the diet, there is a circulation of lipids in your body. However, when blood vessels can become injured, this allows the lipids to seep into your blood vessel and start to accumulate. This starts to form a plaque as it increases, and this could narrow the gap of your blood vessel. So this restricts the amount of blood that flows through your body, and this will have significant impact on tissues. Sometimes the blood vessel could be completely blocked, and this could lead to a heart attack. So ways to overcome this would be quite critical. And heart disease in Australia remains the leading cause of death. It kills one Australian every 12 minutes, and approximately 1,320 people go to hospitals every day due to heart disease complications. Currently, 4.2 million people in Australia suffer from cardiovascular disease, and if we don't control this, this would increase in the future. Furthermore, diabetes increases the risk of heart disease. So people with diabetes can develop heart disease up to 15 years earlier than people without diabetes. And this is because diabetes speeds up the process of these plaque formations. Because there's more sugar, there's more energy in the body, it increases the speed at which these plaques form. So if you have diabetes, you're 2 to 4 times more likely to develop a heart attack or a stroke. And it is the cause of death in amongst 80% of people living with diabetes. Furthermore, this also has significant impact on lower limb amputations because diabetes reduces the ability of blood vessels to grow. And what you'll find is that a lot of people with diabetes will have to have their lower limbs amputated, and this has a significant impact on quality of life. And despite recent advances, many do not respond to current therapies, highlighting the need for alternate strategies. So there are ways in which we can prevent heart disease, and we're taking a multi-pronged approach. So given that atherosclerosis or heart disease develops over several decades, it is critical to find new ways to prevent, detect, as well as treat heart disease. And this is where our group comes in. We're headed by Dr. Christina Bursell, a vascular biologist with over 20 years of experience, and we are supported through a range of very talented PhD students as well as research assistants who are doing multiple different projects in our efforts to address ways to prevent, detect, and treat heart disease. Now, these are some of the approaches that we're using, and I won't go through every single one of them, but I'd like to highlight a few. So we're interested in improving blood vessel imaging capabilities. So when you go and see a doctor and the doctor wants to do a scan of your blood vessels, it is able to assess how well your blood vessels are flowing blood. So if there are clots, the imaging capabilities can assess that. But we are looking at ways to improve that so that clinicians and cardiologists will have more information so that they can provide further treatment. We're also interested in increasing the levels of the good cholesterol, HDL, which I'll describe in a little bit more detail later. And for the remainder of this talk, I'd like to touch on some of the work that we've been doing in terms of promoting new blood vessel growth. Now, as I've said earlier, the blood vessels that supply blood to your body can sometimes become blocked, and this will starve tissues of critical nutrients and oxygen. Now, the body has a natural process to overcome this by growing new blood vessels that can bypass this blockage and then feed back critical nutrients and oxygen back to the tissues. Now, in diabetes, this severely slows down the body's natural ability to do this, and this is one of the mechanisms or one of the processes that underpin some of the complications you see between diabetes linking the risk with heart disease. So therefore, anything that can promote new blood vessel growth in diabetes would be therapeutically beneficial. So we began some of this work over in Sydney at the Heart Research Institute, looking at the role of the good cholesterol. And just highlighting some of the key players, here you see Christina Bursell. This is Hamish Prosser. He was a postdoc with the group who also did a significant portion of this work. And I'll summarize 5 years' worth of work into 3 slides. So firstly, when you go and see the doctor usually takes a blood test, and what he does is he assesses the different types of cholesterol. So I wanted to walk through some of the different types of cholesterol in the body. So HDL cholesterol is a particle that can carry lipids away from your blood vessels. So this takes the lipids into the liver where it's broken down. LDL cholesterol carries lipids to the cells. And if you get too much lipids in the body, you have a higher risk of developing plaques in the blood vessels. So this can build up in the blood vessels, leading to clots. Triglycerides is another form of cholesterol that stores unused calories, providing your body with energy. And total cholesterol is the sum of all 3. Now, there's a fine line between trying to adjust the levels of HDL as well as LDL, and that's kind of the key things that the doctors look for. High triglycerides also influence the degree of heart disease as well, so the doctors also assesses that, and depending on parameters that they look at. So taking this into context, sometimes you hear the thing that LDL is called the bad cholesterol, and this is because this is what it does. It carries lipids and it deposits them into the blood vessels. However, high-density lipoproteins are often called the good cholesterol. So what HDL does, or the good cholesterol does, is it takes up these lipids and removes them. So this fine line between having good HDL to remove the lipids and high LDL could impact your risk of heart disease. Now, over the last 4 decades, there has been significant body of work that show that good cholesterol can be heart protective. And this stemmed from a key Framingham study conducted in the 70s, where they've shown that high levels of the good cholesterol is associated with lower incidences of developing a heart attack. And this is true for both males and females. Now, extensive bodies of work have sought to determine why the good cholesterol can do this. And in addition to its ability to remove lipids from vessel walls, there are also ways that the good cholesterol, studies have also shown that the good cholesterol can also affect the development of atherosclerosis or heart disease. It has anti-inflammatory properties, antioxidant, and our group has shown that it can increase blood vessel growth in diabetes. So here are my 3 slides. So the first thing we did was we looked at cells in culture. We grow cells in a gel matrix, and this allows the cells to form little honeycomb structures, which we term little blood vessels in our lab. So what we find is that when in our cells that were treated under normal glucose or normal sugar levels, the cells can form little honeycomb structures, as you can see here. And this is true in the cells that were treated with HDL. Now, when the cells were treated with high sugar, you can see that there's very little honeycomb network formation presented. However, in the cells that were treated with the good cholesterol, this rescues this impact of high sugar, suggesting that for the first time that the good cholesterol can actually promote blood vessel growth, at least in a cell in the lab. We then moved on to a preclinical study. We conducted 2 clinical models, and the first thing we did was we conducted this clinical model that looks at blood flow return into this in the left leg. So what you can see is non-diabetic animals. We can see increased blood flow return, as you can see by the red and green in the limbs. Now, in the animals that were made diabetic, there was a reduction in the amount of red in the foot. However, in the animals that received infusions of the good cholesterol, there was a significant increase in the amount of blood flow return, as you can see by the increased areas of red, suggesting that there's more blood flow. So it's nice to see that we've managed to see the same thing in cells as well as our preclinical studies. We also did this in a wound healing model. So people with diabetes have a severe impairment of wound healing. Because there is a reduction in wound repair. And I think if you go and see the diabetic foot clinics, there's a lot of people that have to have their wounds debrided and treated because they can't heal properly. And again, we saw a similar thing. So what we saw was that in our non-diabetic animals, we can see that this promotes wound closure, even with the good cholesterol. Now, as you can see in the diabetic wound, that wound is still quite large, so suggesting that it is severely impaired. However, when we daily topically apply directly to the site our good cholesterol, this reduces the wound and heals the wound a lot quicker. And we measured this using our laser Doppler imaging, which measures blood flow reperfusion. And again, we see that this is attributed to the increase in blood vessel growth, as you can see by the higher areas of red and green, compared to very non-existent red areas there. So these exciting results gave us hope, and we are fortunate enough through the support of Diabetes SA to now take this into the clinic. So we are conducting our first human proof of concept trial, which will test the effect of the good cholesterol on wounds in patients with diabetes. And this is spearheaded by Christina Bursell with support of Professor Robert Fittridge, who is a vascular surgeon who has established multidisciplinary diabetic foot clinics in Adelaide, as well as Professor Stephen Nichols, a cardiologist and international leader on the good cholesterol. So we are excited that we've been able to take something from the bench and hopefully take it into a clinical setting. So watch this space in the next couple of years. So switching gears slightly, I'd like to talk to you about another novel target that we're exploring in the lab. And for this section, I'll introduce you to a term called microRNAs. And this project is driven primarily by a very talented PhD student, Emma Solly, with support from Diabetes Australia and through her PhD research scholarship through the Hospital Research Foundation. Now, microRNAs are already present in your body. And what it can do is quite unique, is it can target multiple pathways. Now, you must be wondering what that actually means. So I do have a little video that, if you'll indulge me, which hopefully should explain what microRNAs are. And
Sounds like a recent discovery in biology is proving to be one of the most important scientific breakthroughs in the last decade. Even though they are only tiny molecules, leading scientists are calling microRNAs the master maestros of the genome. MicroRNAs are quite abundant in cells and have a major influence in cell biology. A single microRNA has the ability to orchestrate the expression of broad networks of genes instrumental in normal cell function. As a microRNA regulates the function of several messenger RNAs, it finely tunes a biological pathway, which can profoundly affect cellular activities. As we discover how microRNAs are involved in biological pathways, we'll also be discovering how their dysregulation leads to disease. Typically, when a microRNA is dysregulated, the pathways that are the targets of the specific microRNA go awry, which disrupts the delicate balance and harmony of normal cell function. MicroRNA medicines act by targeting dysregulated microRNAs, resulting in the normalization of genetic pathways and thus halting the disease process. The prospect of targeting microRNAs is very promising because it opens the possibility to a new class of therapeutics and a unique approach to treating diseases. The field of microRNA discovery and therapeutic development is at a tipping point and is growing exponentially. We at Regulus have developed innovative chemistries and acquired a deep understanding of the biology behind diseases caused by microRNA dysregulation. Regulus is uniquely positioned to lead the development of a new class of high-impact medicines based on microRNA. Regulus, targeting the pathways of human disease. To learn more, visit our homepage at www.regulusrx.com.
So I'm not sponsored by Regulus at all, but I thought that was a pretty cool video and gave me a break from talking for a bit. So given that microRNAs can target multiple pathways, and given that diabetes and heart disease is a very complex disease, we sought to explore whether microRNAs can be ideal candidates for the treatment of diabetes and heart disease. So this is early stages yet, but I'd like to share some of the preliminary findings of our studies so far. And what we've seen is that when we target a specific microRNA, we can again promote these little honeycomb networks in both cells in culture, as well as promote blood flow return, as you can see in this red foot compared to our diabetic mouse. So what we're seeing is, in addition to our studies on the good cholesterol, we also find that microRNAs could be a novel target. And this is the focus of a lot of biopharmaceuticals in the future. So what you'll find is you'll hear about microRNAs more and more often, hopefully. So as I've said, so this is just to summarize some of the findings that we've shown so far, and we are looking forward to spending the next 5, 10, maybe more years in terms of identifying new therapies. But just to give you an idea of how long these developments sort of take. So we, as I've said, we go through a discovery stage, and then once we have some key findings, we can then take this into a clinical phase. And there are several checks and balances, obviously, to make sure that all these treatments do not cause adverse effects. So excitingly, I can say that our studies on the good cholesterol are now entering a clinical trial phase. And while preliminary findings show promise so far, our microRNA studies are still at its early development and discovery phase. So watch this space. And this will take potentially, hopefully a little bit quicker, but usually from discovery to bench, it might take anywhere between 15 to 20 years. So hopefully we might be able to speed this up a little bit for you. But in the last couple of slides, I want to talk to you about what you can actually do to reduce the risk of diabetes, because there are ways that you can change your lifestyle and reduce your risk of incidence. Now, the American Heart Association has established some key parameters or key metrics, and they've termed it the Life Simple 7 journey. So as I've mentioned earlier in the early part of my talk, there are risk factors that you can actually change. So some of these things include stopping smoking, getting active, and getting active doesn't necessarily mean you have to hit the gym for hours and hours on end. If you get up and walk for half an hour every day and start building up your momentum there, it does help make your heart, give your heart a little bit of exercise and help pump the blood through your vessels. Obviously, controlling cholesterol and managing blood pressure is key, so talk to your doctor about these parameters and ways that they can help manage that. Given that lipids causes the clot of blood vessels, it is important also to eat healthy. So managing your diet and being aware of some of the foods that you eat is very key. So talk to your nutritionist. Losing weight is also a way to reduce your risk of incidence, and also reducing blood sugar. And studies have shown that making small changes every day can lead to big improvements in your health overall. So if you achieve the ideal status for at least 4 of these simple 7 metrics, this lowers your incidence of diabetes by 75%. Furthermore, if you add an additional metrics, this cuts your risk of heart disease by 50%. So making some of these small changes would help you maintain your heart health and in the future. Furthermore, given this is a diabetes info session, it is important to know your diabetes ABCs. And given that I'm not a doctor, I am a basic scientist, I would strongly advise that you go and see your doctor and/or credentialed diabetes educator to discuss some of the risks. So the ABCs involve A1C levels, and this is a reflection of your blood sugar levels over the last 3 months. And the goal is to achieve a less than 7%. High blood pressure can increase the risk of heart attacks, so your doctors will aim to treat that and with the goal of reducing that to about 130/80. As I've mentioned before, the bad cholesterol is what accumulates in your blood vessels. So by adjusting your levels of the bad cholesterol, this could reduce the impact of clogging up your blood vessels. So again, aiming for an LDL cholesterol less than 2 millimoles per liter is kind of what the doctors look out for. And there are medications, but there are also lifestyle changes that you can do to reduce all of this. So some of the take-home messages. If you learn anything so far, well, hopefully I've managed to convince you that diabetes increases the risk of heart disease. A lot of people do not actually know the link between heart disease and diabetes, so hopefully I've given you some insight into how this these two diseases are so closely related. I've talked about some of the novel agents that we're working in the labs to treat diabetes and heart disease. I've touched briefly on good cholesterol, and that's work that we've been working on for the last 8 years or so, and it's nice to kind of see that translate into a clinical setting now. Our microRNA stories are a little bit early in the early phase, but we've seen some promising findings that we hope will speed up its translation into the clinic, and maybe Regulus might be able to sponsor me. And finally, small lifestyle changes can lead to improved health, reducing the risk of diabetes and heart disease. So you can take control and you can do small lifestyle changes that can reduce the risk of heart disease and diabetes. And if you take anything from this talk, I would highly recommend that you go and see your GP and get your Medicare covered heart health check, which was instated earlier this year. And finally, I'd like to thank everyone for listening. I hope that's been informative, and hopefully we can take diabetes to heart and reduce the risk of heart disease. Thank you.